Alright guys, let's go ahead and finish up the rest of the notes for a law of cosines. We left off looking at this last problem, example 4 down below. Now I do have my graphing calculator off to the side, so you won't be seeing me do the calculations, but feel free to always pause the video and do the work yourself if I am going too fast. Alright, so let's go ahead and begin with example 4. We're going to draw this triangle in, knowing that we have angle A in the lower left corner. That's going to be 35 degrees. And then we have side A to the opposite of that, but there is no A value here, so let's leave that alone. But we do have that a B value is 5, and a C value is 8. Now because we do have a side, an angle, and a side, that gives us an SAS congruence theorem from geometry, so we know we're dealing with a unique triangle, which means we can just solve this one triangle here. Now if we think about what we can use, you have law of sines and law of cosines. Law of sines won't work here because if you just think about doing sine 35 over A, it's equal to sine of, let's say, B over 5. There were two variables there, and so with two variables, we just can't solve that. So instead, let's go ahead and try law of cosines. So we're going to say that with this angle here, we go opposite of that. So therefore we see a squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 35 degrees. So if we put that into our calculator, 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 35 degrees, we get 23.47. We'll have to square root that, and my calculator got 4.84. So with that value, that's finishes getting all three sides here. Now we need to find the other two angles. So since we have 4.844, now we can actually use the law of sines and say sine of 35 degrees over that value, 4.84, is equal to, let's go ahead and solve for b first. Sine of b over, the b value is 5. And from there we can move the 5 over 4.84 sine 35 will give us sine b. And now let's just enter that into the calculator. And don't forget that you need to arcsine it. And so after you arcsine your value, you'll get that angle B is a value of 36.29, or since we see 0.299, let's just say that's 36.3 degrees. So that's angle B. Since we have angle B, we now need to find our remaining angle. Let's call that angle C. And so angle C is just 180 minus 35 minus 36.3 degrees. So in our calculator, just type that in, minus 35, and we will get a value for angle C of 108.7 degrees. Okay, so that concludes example 4. Let's go on to the next page. Example 5. Solve the triangle. So if you'll notice, we do have 3 sides, so that'll be a side, side, side. That's a congruence theorem again, so just like the last problem, we'll get a triangle. It's a unique triangle, and let's just label the sides as A equals 6, B equals 8, and C equals 5, and then just put the respective angles where they belong. And it looks like all we need to do then is find this angle measures rather. So since we have all 3 sides, again, law of sines won't work because we don't have any angles, so we wouldn't be able to put that into our law of sines at all. So instead, let's do law of cosines. It doesn't really matter what you pick. Let's just say we want to solve for angle A. If we want to solve for angle A, we start off by saying 6 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of, oh, we don't have it. Let's call it angle A. Okay, so in our calculator, we got to do 6 squared minus 5 squared minus 8 squared. We'll get negative 53, and then negative 53 will have to be divided by negative 2 times 5 times 8, so that we can solve for cosine of A, so just take that, divide it by -2 times 5 times 8. And then lastly, remember that since cosine is by itself, we need to arc cosine that value. And so we're getting that angle A is a value of 48.51 degrees. Okay, so now that angle A is 48.51 degrees, we can now use our law of sines to find the other two angles. So let's go ahead and find angle, let's go with B. So 48.51 degrees over 6 is equal to sine of B over B is related to the value of 8. Okay, so if we just have 8 over 6 sine 48.51, we can set that equal to sine B and then solve for angle B. So in our calculator, we type this in and we're going to get arc sine of that. Gives us a value of angle B should give you 87.15 degrees. Now look, we have two angles. To find the third angle, that makes it nice and easy. A triangle has 180 degrees. Subtract angle B and subtract angle A. You have your two values up above. So let's go ahead and do that. 180 minus 87.15 and also 48.51. And we will get an angle C value of 44.34 degrees. Okay, so that completes example 5. Now we can go ahead and go on to example 6. So in example 6, let's see what we have here. An airplane flies due north from Fort Myers. I'm just going to go ahead and draw it down here. We've got Fort Myers. An airplane is going due north, meaning they're going straight up, due north, like that, to Sarasota. Sarasota is going to be right here. Let's call that S. And the airplane went 150 miles. So we'll put 150 to that. And then turned at an angle of 50 degrees. So remember what we said before, when we're talking about bearings, 50 degrees comes from the north, and they're going 50 degrees clockwise. And so from here we can draw another line this way. Now the plane heads in this direction, northeast, and flies to Orlando for 100 miles. So we'll go 100 miles this way, and then we'll place Orlando right here. Let's call it O for Orlando. Alright, so there's the drawing, and how far is it directly from Fort Myers down below to Orlando? So what we're looking for is this distance right there. Let's call this x. Okay, so if we want to find x, I guess it's important to find this angle here. Huh? Let me do this in blue so you can see it easier. So if we know that this is 50 degrees, that must mean that this is 40. And we know this is a right angle, 90. And altogether, that's going to add up to 130 degrees. So we have 130 degrees there. Okay, it's getting a little messy. I'm just going to go ahead and redraw this triangle so you can see what we're dealing with. What we have is a 130 degree angle here. We've got 100 feet. Is it feet? No, not feet. That's ridiculous. That's 100 miles. 100 miles here, 150 miles over here. And what we're looking for is how far away this line is. What does this look like to you? It looks like law of cosines, right? That's how we're going to find B, the law of cosines. So let's go ahead and solve this. We've got x squared equals 100 squared plus 150 squared minus 2 times 100 times 150 times cosine of 130 degrees. Alright, enter that into the calculator. 100 squared plus 150 squared minus 2 times 100 times 150 times cosine of 130 degrees, and then don't forget to square root it, and we'll get a value of 227.56 miles away. That's your answer to B. 227.56 miles away. Okay? Alright, letter C. what bearing should the pilot use to fly directly from Fort Myers to Orlando? So what we want to find the bearing is, we got to find this amount. Well, then that's asking us what is this angle, right? So let's go ahead and find that angle. Let's see. We know that this value is 227.56. We got its opposite angle. This angle would be opposite side over there. That sounds like we can use law of sines, right? We'll do sine of 227.56 degrees over, oh, what am I doing? Not 227. Sine of 130 degrees. Sine of 130 degrees over the length, which is 227.56, equals sine of the given angle over 100. And so to solve for this, let's do 100. Let's bring 100 over to the other side. Oops, times sine of 130. And then that'll give us sine of theta. And then we'll have to arc sine that value. So in your calculator, go ahead and enter 100 divided by 227.56. Multiply that by sine of 130 degrees. And then lastly, we need to arc sine that answer. So we get that theta is 19.67 degrees. Well, if we want to find the bearing, keep in mind we can give it in two different forms. One of those forms is saying, well, we're starting from the north and we're going in this direction, so that'd be north 19.67 degrees east. That's one way to say it. Or the other way is really just, I guess 020 if you round that to the nearest degree. That'd be like basically 020 degrees. This answer would probably be the more exact answer just because you do have the decimal value. Just imagine if a plane were to go 20 degrees rather than 19.67 degrees, they'd be going a little bit in the wrong direction. So you want to make it the most exact answer possible, which means the first answer would probably be a better choice. Okay, so that'll conclude this lesson for today.